So this one is talking about average rate of change, the slope of a line. You're familiar with finding the slope of the line between 2 points, but average rate of change can also refer to how non-linear function changes between 2 points. So the graph to the right shows an exponential function, and the line between 1 and 4 is showing you the average rate of change between those 2 points. So there's another thing called instantaneous rate of change that we're going to hear a lot this year and in Unit 1. That's also a slope of a line, but it's the slope at only 1 point. So on this graph, it's telling you how the rate of change is changing at a specific instant. So the other line is instantaneous. So this one right here is the instantaneous rate of change at that 1 point. So you might ask, how can you find slope if you only have 1 point? So that's something that we're going to learn that's new today. So this first part is just reviewing with you how to find average rate of change. You don't have to do anything here. It's just showing you the notes. Your first step would be to generate the values at 4 and at 6. So plug in 4 right into the function, 3x squared plus 1. So they're taking the coordinate, what'd they say, 4 generated 49 and 6 generated 109. So you need 2 sets of points to find average rate of change. Then they did y2 minus y1 over x2 minus x1. Does that sound familiar, I hope, from Algebra 1 and Algebra 2? And then they did 60 divided by 2 was 30. So the average rate of change, the slope of this line right here is 30. Rise over the run, it rises 30 and runs 1. So to find instantaneous rate of change on this graph is tricky. They want the instantaneous rate of change at 5. Oh, sorry, at 2. That's 2. So they want you to generate 2 points, right? Because slope is 2 points. So they're using points that are really, really close to the number 2. So they're using the points 1.99. When they plugged it into the function, they got this number, 12.8803. And they're using the point 2.01, 13.1203. So to find instantaneous rate of change, you really still need 2 points. And they're picking the points that are really close to x equals 2. Then, once they have the 2 points, they're just doing the slope calculation again. y2 minus y1 over x2 minus x1. So the instantaneous rate of change is 12. So that's telling you that this average rate of change was 30, and this instantaneous rate of change was 12. That looks reasonable, right? This line looks steeper than this line. So we're going to be using that average rate of change calculation quite a few times to be able to practice that skill. So I'm going to do it with you first on this function. So here's a new function, 3 raised to the x power minus 5. So we're going to calculate the average rate of change between 2 and 3, the average rate of change between 3 and 4, and the instantaneous rate of change at 3. So this is a great one to use your calculator table of values for. So I want to show you where the table of values is in case you've forgotten. So can everyone grab a graphing calculator to make our life easier on this problem? So in your y equals menu, 2 things. Clear out if there's a function in there and turn off the stat plot. So if your plot 1 is black, scroll up, hit enter on it, turn it off. Your plot should be not black because you're not doing a scatter plot. So in your y equals menu, grab a calculator if there's not one next. It's on the back. Keep going to the back. Are there any left? Keep going to your left hand. Are there any left in there? Or are they empty? You got it. All right. In your y equals menu, type in 3 to the x minus 5. So 3, that upwards caret. Everyone know where that key is? 3 raised to the x power. Use the variable key, arrow over, and then minus 5. Make sure you use the minus sign, not the negative sign. right? There's a difference. That's the negative sign, that's the minus sign. It'll multiply it instead of subtract it. Is everyone okay on how to type that in? To raise it to the exponent, you type exponent. Oh, the x key is right here under mode. See x comma t comma theta comma n. That's the variable key. So it's actually this key. 3 raised to the x t theta n, and then the minus t minus 5. Yeah, alpha x will work. It just, you're running the risk of someone storing information in the calculator. Like if someone stored that x was 7.9, then you're plugging in 7.9 and not the variable x. But most of the time, alpha x will work. I just like to use the variable key. Okay, so then hit the zoom key because we want to take a look at this graph. Zoom, I'm just going to hit zoom 6 for standard view. So this is just, we're making sure that the graph, exponential graph is showing up in our calculator. We don't have any issues with things, right? Did you get that graph to show up? Because then I know you entered it right and the table is going to show up correct. Okay. So now we want to go in our table. We want to find the values at 2 and at 3. So I think some of you could just hit the table key, but let's do table setup first. So it's above the word window, second table, or second table setup. Let's start at 0 and count by ones. So hit second table setup, start at 0 in your table and count by whole numbers, ones. And then you should be able to go to second table, which is above the word graph, and your table value should show up. Does anyone need help? We skipped on to 106. So we're at the first part of 106, the back page. You can jump right in with us. So we plugged in this function into our graphing calculator. Did everyone get the table to show up? Because I'm going to record the values with you, and then you're going to do the average rate of change calculation. So my 2 points for number 1 here would be 2 comma 4 and 3 comma 22. Are you with me in your table on where I got those values from? Right, 2 comma 4 and 3 comma 22. And then I'm going to record 3 comma 22 again. And in our table, what did you get for 4? 4 comma what? 76. So we'll come back to that in just a second. How am I going to get my points for number 3 here? They want the instantaneous rate of change at 3. I need to use 2.99 and 3.01, and I need the corresponding y values at those two x values. So I need to actually change my table so that I can see 2.99 and 3.01. So you go back to table setup, so second window. This time we want to start at 3 in our table and count by 0.01 on either side. And that way I'll be able to see 2.99 and I'll be able to see 3.01. So second table setup, change it to starting at 3, counting by 0.01, and then you can go to second table, which is above the word graph. And if you arrow up, then you'll be able to see 2.99, what that corresponds to, 3.01, what that corresponds to. So to me, that's the hardest part, is just pulling all those values out of the function in the table. So at 2.99, we're at 21.705, and we're at 22.298. So now for each of these, you have 2 coordinates, and to find slope, y2 minus y1 over x2 minus x1. So you're coming up with the average rate of change and the instantaneous rate of change on the graph. So now I want you to take these 2 points and actually take y2 minus y1 over x2 minus x1. See what you get. Does anyone have questions on what to do next? We'll just see if we can pull the right answers out of here. So if I type in the 22.298 minus 21.705 without parentheses. You just want to hit enter first and then divide it by 0.02. I usually don't even do this subtraction because anytime you're doing instantaneous rate of change, this difference will always be 0.02 because you went 0.01 below and 0.01 on the other side. So the difference in x's will always be 0.02. So I just take what I get and divide by 0.02 as a shortcut. But does that kind of make sense how to do average and instantaneous rate of change? Because now I'm going to have you work on, there's some guided practice that you are actually going to do. So they're giving you a table of values and you're calculating average rate of change. We might want to do the scatter plot part together again. Do you want to do that part together first, maybe? Because we typed it in quickly with open box, but let's actually, so this is the height of a soccer ball punting through the air, taking some time-lapse photography so they know the height of the ball, different time through the air. So it basically goes up and then it comes back down. So you can go back and do this in a minute because this is just average rate of change using those table of values. But let's actually come up with our scatter plot on the graphing calculator together. So that's under Stat Edit. So if you want to look under Stat Edit, you probably have some data in List 1 and List 2 from the other class. So to clear out your lists, you can hit the arrow up key on List 1 and then hit clear enter. Arrow up, clear enter to clear your list. This is all under Stat Edit. All right, so then we're going to put our data in List 1 and List 2. So, oops, I'll give you a minute to Stat Edit. Okay, so you got 0, 0.5, Does anyone need help entering the data? You all are on the right track for that? Okay. Because you're going to be using regressions a lot this year and finding the correct model for different situations. And I need to write a note to myself that I was going to print off for you the regression resource, because I don't think I did, right? Put that in our resource part, regression resource, Precalc. Because that'll have all these steps. Did everyone get their data put in there? So then you need to go to second y equals, because that's stat plot. Turn that back on. And then zoom 9 will give you the view of your scatter plot. So second stat plot, turn that one on. And then zoom 9 will give you the view of your data. Just plot 1, because you just have one set of data, one scatter plot. So you just turn on plot 1 and then hit zoom 9. So it does look like a quadratic, right? So you have to know kind of what type of model are we looking for? Square root, absolute value, linear, cubic. So that's why it's important to know just in general what type of parent function you're looking at so that you can actually, it just says graph a scatter plot, right? So there's my scatter plot. But they want you to actually calculate a regression. So I'm skipping 1, 2, and 3, or 1 and 2. You can come back to those. What parent function? Quadratic. And then find a regression equation. Here were all the steps. So I kind of did the steps with, or I will do the steps with you. So did everyone get their data to show up on the graph first before we try to do the, all right, so you're going to type now, stat calculate quad reg. That stands for quadratic regression. So go under the stat key again, calculate quadrag, because it's a quadratic, choice 5. And then the only other thing that's nice to do is to store your regression equation so that it goes right into the y equals menu for you. It's under vars, y vars, function, you'll see y1. So when your cursor is here, vars, y vars, function, y1, it'll store it for you. That way you don't have to type it in. It's a long equation. So vars, y vars, function, y1. See how y1 will show up where your cursor is, and then you can calculate. So it's giving you the A, B, and C value of the quadratic in standard form. So you can go ahead and record the abbreviated equation. It's y equals negative 4.9x squared plus 18. I'm just going to round to 18x plus 1.008.
Where do we write that?
It says write down the regression equation. There's like a line. Say record your regression equation to it says 4 decimal places. Sure. Y equals, we already put it into our y equals menu, so that's not as important. Plus 18x plus 1.008. But we've stored it in our y equals equation. So why don't you go back, now that you've got your regression equation, we're here till what, 10:20. So you've got another, 6 or so minutes to work on this problem. We'll be finishing this one up next time, but we've done the regression equation, so you can either continue on and do 5 and 6, or go back to do 1 and 2 before you move on to 5 and 6. But we're going to end up finishing it probably next time, but take a few more minutes to try the rest of that part.